We've decided to segregate the signing keys from the wallet by implementing cold storage, which means keeping the signing keys offline at all times. We've also decided to use multiple signing keys rather than a single one. This will tremendously increase the security of our vault. But we need to go one step further. If I distribute the keys among my heirs, what guarantees do I have that they won't collude to take the funds out of the vault before the right time? Remember, the goal of this vault is to implement self-inheritance. To do this, we will only trust family members and relatives. What if we could separate our trusted relatives in two categories, the guardians and the heirs, in such a way that the heirs wouldn't be able to collude and take the funds out of the vault by themselves? What if we could separate each signing key into two elements, one that goes to a guardian, the other that goes to the heir? That way, the guardians wouldn't be able to collude between themselves and take the funds out of the vault, nor could the heirs collude between themselves to do the same. We'll dive deeper into the relation between guardians and heirs later. For now, we will explain what will allow us to divide the signing keys in two. Let's explore the concepts of seed and passphrase. A seed is a very large piece of data, a number that is generated out of randomness. It can be used as a signing key by itself. As a matter of fact, most signing keys are seeds. We call it a seed because the wallet and all its addresses, which can be represented in the form of a tree, are derived from this single very large random number, this seed. The seed generally takes the form of 12 or 24 words, so that us humans can easily read it and copy it without making mistakes. A passphrase, on the other hand, can be any string of data that will be added on top of the seed and will turn it into a completely new and different signing key. A passphrase is not a code, not a password, but a modifier. Added to a seed, it will modify it into a completely different signing key. Let's take a look at a diagram to better understand how this works. On the left, we have a signing key which is composed of a simple seed. So in this case, we would generate a seed and it would effectively become our signing key. Seed A would be signing key A. The signing key would be the seed by itself. In the second case, we would have seed A, which by itself would create signing key A, but on top of it, we would add a passphrase. Once you add the passphrase on top of seed A, you won't get signing key A anymore. You will get a completely different signing key, and in this case, I called it signing key B. The interesting thing to take into account is that you can create an infinity of passphrases that you can add on top of the same seed, and each passphrase that you add on top of the seed A will create a completely different signing key. This is how we can separate one signing key into two components. One would be the seed and the other would be the passphrase. We'll see later how we can use that in our vault. We now understand what the difference is between a seed and a passphrase, and how adding a passphrase on top of a seed creates a completely different signing key. So how exactly will this serve our purpose of separating the heirs from the guardians, and how will this benefit the overall security of the Bitcoin vault? This is what we're going to see in the next video. See you there.